What if you could see the universe through an eye the size of our entire planet? I'm not talking about faint dots of light. I'm talking about seeing the actual continents on an alien world, or watching space-time get twisted into a pretzel at the edge of a black hole. It sounds like complete science fiction, but I'm going to let you in on a secret. We've already built a telescope the size of Earth. That's right. Using a network of telescopes all over the globe, the Event Horizon Telescope took the first ever picture of a black hole. But that was just a test run. That was in radio waves. What if we did it with visible light, the light your eyes see? What if we built a true planet-sized camera with a resolution so insane it would feel like we were breaking the laws of physics? The secrets we could find wouldn't just fill books, they would literally rewrite them. To understand why a planet-sized telescope would be the most insane thing ever built, you only need to know one thing. Size is everything. The bigger a telescope's mirror, the more light it collects, and the sharper the image is. Think of it like pixels on your phone screen. A bigger mirror gives you an insane pixel count, turning a blurry mess into a crystal-clear picture. Even the incredible James Webb Space Telescope, with its giant 6.5-meter mirror, is tiny compared to what we need. It's looking back to the beginning of time, but the first galaxies are still just reddish blobs. To actually see inside those galaxies, you'd need a mirror that's impossibly huge. So how do you build a telescope bigger than a rocket can carry? You do it with a crazy technique called Very Long Baseline Interferometry, or VLBI. Instead of one massive mirror, you take a ton of separate telescopes spread across the world, and you link them together with supercomputers. By doing this, the distance between the two farthest telescopes becomes the diameter of your new virtual telescope. That's how we turned planet Earth into a camera to see a black hole. The idea is simple, but actually doing it is ridiculously complicated. For this to work, every single telescope has to stare at the exact same spot at the exact same time. The signals they get are time-stamped with atomic clocks so insanely accurate they lose just 1 second every few million years. There is so much data, petabytes of it, that it can't be sent over the internet. They literally have to fly the hard drives on airplanes to one location where supercomputers do the impossible job of mixing it all together. The computers line up the light waves from every telescope perfectly. When the peaks and valleys of the waves match up, they create a signal that is unbelievably more detailed than any single telescope could ever get on its own. It's a symphony of data on a planetary scale. But here's the catch. The Event Horizon Telescope sees in radio waves. The real revolution, the one that lets us see alien continents, is to do this with optical light. And that is thousands of times harder. The wavelengths are so much smaller that the level of precision you need is almost impossible with today's technology. But scientists are already planning it. Imagine a fleet of space telescopes, flying in perfect formation, thousands of kilometers apart. Linked together, they would create an optical telescope in space, a planet-sized eye, with no atmosphere to blur the shot. This is the machine that could show us the universe in a way no one has ever seen before. So what would we actually see with this thing? Let's start with the scariest things in the universe, black holes. The pictures we have now are history-making, but let's be honest. They're basically blurry donuts. With a planet-sized optical telescope, that blur would snap into focus with terrifying clarity. We wouldn't just see a shadow. We'd see the photon ring, a razor-thin circle of light made of particles that have orbited the black hole multiple times before escaping. We would see the river of gas and stars feeding the beast, not as a glow, but as a chaotic space storm ripping matter apart. We could literally watch a star get eaten, screaming with a final flash of light before it vanishes from our universe forever. This isn't just for cool space pictures. This is the ultimate physics test. By seeing the edge of a black hole this clearly, we could finally prove if Albert Einstein's theories were 100% right, or if they start to break in the most extreme place in the universe. We could literally break physics with this telescope. For all of history, every single star you see in the sky, except our sun, has been just a point of light. And the thousands of alien planets we've found? We only know they exist because we see the star's light dip a little. We can't actually see them. We have no idea if they are water worlds, desert planets, or another Earth. A planet-sized optical telescope would change that overnight. An exoplanet like Proxima Centauri b would go from a number on a chart to an actual place. We could resolve it into a disk A tiny disk, but a disk with features. We could literally create a map of its surface. We could tell the difference between a blue ocean and brown and green continents. We could track white clouds and figure out the weather on a planet light years from here. The search for life would go from a game of statistics to direct observation. We could look for the red edge, a telltale sign of something like chlorophyll from massive forests. We could watch seasons change as ice caps grow and shrink. For the first time ever, we would look at another Earth-like planet and ask not, could life be there? But what does the life there look like? Answering that one question would change our world forever. As crazy as that is, the most profound thing a planet-sized telescope could do is look back to the beginning of time itself. The James Webb Telescope was built to see the first galaxies, but even for Webb, they're just faint, blurry smudges. We know they're there, but we can't see what's inside. With the power of a planet-sized eye, we would zoom in on those smudges and see the very first stars to ever exist. These were the legendary Population 3 stars, absolute monsters made of only hydrogen and helium, hundreds of times bigger than our sun. They lived fast and died young, exploding and creating the first heavy elements, which is the stuff we're all made of. We could watch them being born. We would also see one of the most incredible events in history, when the lights in the universe turned on. For millions of years, the universe was filled with a thick, dark fog. The insane radiation from these first stars burned through that fog and made the universe transparent. It would be like having a front row seat to the universe's own origin story. So, let's recap. We could take a high-def photo of a black hole eating a star. We could make a map of an alien planet's continents. We could watch the first stars being born. Any one of these would be the single greatest discovery in human history. Every time we've built a bigger eye to look at the sky, from a tiny telescope to the Hubble, we have found things more wonderful and more insane than we could have ever predicted. It always shows us that the universe is bigger and we are smaller than we ever thought. An eye the size of a planet is the final step on that journey. It's a machine born from our need to know what's out there. A telescope like this wouldn't just show us the secrets of the universe. It would show us a new version of ourselves. A species that finally looked out into the great dark ocean of space and saw, with perfect clarity, the other shores waiting for us. The scale of this is mind-blowing, so I have a challenge for you. If you had control of this telescope for just one day, what would you point it at? The edge of a black hole, a promising new planet, or the beginning of time itself? Tell me your choice in the comments below.